Welcome to the machine learning series. In today's video, let's build a simple classification model, logistic regression. First, let's understand what logistic regression is with the help of a problem statement. Let's take a healthcare example. Suppose doctors want to figure out if a tumor is cancerous or safe. They collect measurements like size of the lump, smoothness, thickness, shape, and many more. Now, the machine learning model's job is to look at these measurements and answer, yes, it is cancerous, or no, it is safe. This is called as classification, putting things into two different boxes. Logistic regression is like a smart thermometer. A thermometer measures temperature and tells you if it is above 100 degree Fahrenheit, you might have a fever. If it is below, you're fine. But in real life, it's not always that clear. What if it's 99.8 degree Fahrenheit? That's almost fever. Maybe, maybe not. So instead of giving just yes or no, logistic regression first gives a probability, a number between 0 and 1. It does this using the sigmoid function. Now, what is a sigmoid function? Think of the sigmoid like a slide shaped like an S. Very low scores slide down to 0, almost definitely cancerous. Very high scores slide up to 1, almost definitely safe. In the middle, around 0.5, it is unsure. Imagine the model looks at a tumor and says, I think it is 95% likely to be benign, so predict this as benign. Or, it is 10% likely to be benign, so predict this as malignant. So the cutoff is usually determined based on the use case. For example, if it is 0.5, above 0.5, it is safe, and below 0.5, it is cancer. Let's start coding this logistic regression in 5 simple steps. The first step is to set up the environment by importing the required libraries and packages. First, let's import the dataset that we are going to use to build the classification model. Next, we have already seen in our linear regression tutorial that to build a model and to train it, we need a training data. And to test the model's performance, we need testing data. To split our data into training and testing, let's import train test split. As we are going to build a logistic regression model, let's import that as well. Finally, to check the performance of the built model, let's import accuracy score. Step 2 is to load the data set and split the data into features and target. Do you remember what is a feature and target we discussed in the last video on linear regression? Features are the input variables using which the model we are building learns to predict the target, that is the output. Let's load the data set now and split it into feature and target. Load breast cancer loads the cancer data and we store it in a variable named dataset. Now dataset.data contains the features. Let's store it as X. Dataset.target contains the output variable. Let's store it as Y. Now let's see how the input and output data looks like. Input, that is features, contain various parameters like radius, perimeter, smoothness, etc. These features describe what parameters are closely related to cancer. The output contains zeros and ones indicating whether these input features correspond to cancer or not. Now step 3. Step 3 is to do the splitting. Let's do that. We all know that train, test, split splits the input X, output Y into training data and testing data. Test size determines the ratio in which the splitting has to be done. 0.3 as test size splits the data into 70% training and 30% test data. Last time we discussed why do we need random state. Remember, it's to get the same results when you're building the model. That is, split into training and testing happens on same set of samples. Let's save them into X-train, Y-train, X-test and Y-test variables. Fourth step is to build the model and train the data. Let's do that. Let's initialize the logistic regression model. Let me know in the comments what does this parameter max iterations mean and its purpose. Okay, let's train this model using fit by giving X train and Y train as inputs. Let's execute this. Now our model is ready. Now the final fifth step is to test the trained model's performance. For that, let's do the predictions on the test data using predict. Now predictions would be ready if we execute this code. Now we have to compare those predictions with the original results to find out the performance of the model, right? So let's do that as well. Here, accuracy score helps to find the accuracy of the built model. We give the predicted values and original values as input to find the score. Let's execute this to check the result. Great. This shows that the trained model has 93% accuracy. Please check the description below to download the Collab notebook in which we coded the logistic regression for your reference. So what did we do today? We built a logistic regression classification model in 5 simple steps. We built a classification model to predict whether a person has cancer or not. But why is it called logistic regression instead of classification? Want to know more such details? Then join Interview Kickstart's machine learning program. Learn machine learning from Frank Plus experts who have really built the machine learning models themselves in your dream companies. To know more about this program, join the webinar by clicking on the link provided in the description. Now, just imagine this scenario. Imagine your dataset has 98 healthy patients and only 2 cancer patients. Now, suppose your model predicts everyone as healthy, it still shows an impressive 98% accuracy. In reality, your model has completely missed both the cancer cases, which are the most critical to detect. So even though the accuracy looks high, the model is actually failing at its main goal, that is identifying people with cancer. So accuracy as a performance metric fails to capture whether the model is really good or not, isn't it? It doesn't capture whether the model is reliable or not. Then what should we do? What metric to use? Let's decode that in our next video. Stay tuned until then.